Hi, hello everyone. Good morning and good evening to whichever part of the world you are in. I'm Chanukya, founder of DeFi and today's host for the session. A very warm welcome to each one of you for today's session where we will learn how to classify emails into spam and inbox. And further, we will be using Alibaba Cloud that will allow us to scale millions of requests using these features. And this session is part of Alibaba Cloud's Community Day. And to deliver this, we have a special guest with us, Mr. Jeremy from Alibaba Cloud team. To give you some more context about Jeremy is an engineer at heart and a seasoned technical instructor at Alibaba Cloud. He loves solving problems using technology by creating innovative solutions. And once again, thank you, Jeremy, for joining us today. And it's over to you. And we would love to learn more about the applications of cloud and also how we can actually build a classification algorithm that will classify the emails into spam and inbox. It's over to you. Thanks for joining us. Yeah.
All right, thank you very much for the warm welcome. I'm really looking forward to it. As was said, I've been a technical instructor with Alibaba Cloud for a while now. I've been with Alibaba for about 5 years. And it's the last, because of COVID, for the last for the last more than a year, we haven't been able to do that many events. So it's really nice to be able to get to do a community event again. Um, I think I'd like to start out just by pointing out that what we're going to do today actually isn't that difficult. I think it will only take me about 30 minutes to explain to you how to do the spam email classification, how to train the model, all of it. Because when you're using Platform for AI, which is Alibaba Cloud's machine learning tool, everything's very straightforward. A lot of the setup is done for you. I think you'll be surprised how simple it is. And with that, I think I'll go ahead and get into the heart, the meat of today's session. So here we go. All right, hold on just a second. I need to make sure my screen share works. I might have to restart the screen share. Hold on a second. There we go. Session on AI and machine learning with Alibaba Cloud. I am Jeremy Pedersen. I'm a training advisor with Alibaba Cloud's international training team. Today I'll be talking to you about Platform for AI, which is Alibaba Cloud's machine learning tool. We're going to have a demo after the slides here where I show you how to classify spam and non-spam email using the Pi DSW service. But before we get into that, I want to start with some general overview. So I'll start by talking about AI and machine learning in general. We'll then take a look at Pi itself, the Pi platform, and then specifically I'll talk about DSW, which is a Jupyter notebook environment on Alibaba Cloud. Let's start out by talking about AI or artificial intelligence in general. What exactly is it? So it might help to approach this first by looking at what type of systems require intelligence. So things like face recognition, voice print recognition, machine translation, intelligent security, even smart home appliances, these are all systems that require a certain level of machine intelligence or artificial intelligence in order to work correctly. So the goal with machine learning is usually to approximate some aspect of human intelligence. And of course, there are multiple aspects to human intelligence: logical and mathematical reasoning, visual and spatial reasoning, body or kinesthetic reasoning. So when you do something like throw a ball towards a target, how do you hit the target? Usually you don't need to think about this at all, but it's an ability we innately have. This is something our brains allow us to do: throw a ball at a target, and most of the time we can hit it. Musical or rhythmic intelligence. Then there's intra and interpersonal social intelligence, so the ability to understand yourself as well as the ability to understand other people, predict their moods and emotions, react. And then there's verbal and linguistic intelligence as well, the ability to understand the nuances of spoken and written language. And most artificial systems attempt to do one or more of these things. So the concept in AI is to build a computer system or a computer program that can take reasonable actions and obtain the best outcome. And usually that's because the AI task has a well-defined performance measure. So for instance, later on, when we classify email, we want to classify spam and not spam. The more accurately the system does that, the higher its performance. So when we think about AI, we're talking about systems that think or act like humans, or systems that think or act rationally. There are two general types of AI. There's what's called artificial general intelligence, and then there's artificial narrow intelligence. So, artificial general intelligence focuses on building all encompassing AI systems that try to include most of the areas of human intelligence that we looked at just now. Artificial narrow intelligence focuses on getting the right results in a particular domain, like recognizing faces in images, tracking faces, identifying people in video, reading characters in an image. Things like that are tasks in artificial narrow intelligence. And I'm sure you've heard the terms AI, machine learning, and deep learning possibly used interchangeably. Actually, they do fit together. AI, artificial intelligence, is the broadest category. Artificial intelligence actually encompasses machine learning as well as other techniques for approximating human intelligence. And then within machine learning, deep learning is actually a subset of the techniques within machine learning. So they nest sort of like Russian nesting dolls. The outermost shell is AI, the field of AI. Within that, one of the techniques is machine learning. And within the field of machine learning, one of the ways to train and build models is a technique called deep learning, which involves multi-layer neural networks. And of course, a lot of these ideas have been around for 60 or even 70 years in some cases. The thing that's really different in the last 10 or 15 years is that we now have cloud computing and we have vast amounts of user data on which to train these systems. And that's really why machine learning and AI have become more powerful recently. It's because there's more data and more processing power. So what are some of the strengths of AI? Well, one of the obvious strengths is that computers are built to compute. A computer can run through or process far more data than a human being can in far less time. AI models can therefore consider vastly larger sets of training data than a human can, and can therefore theoretically have more experience than a human can. This makes it possible for machine learning systems to approach problems that might be too large or too complex for any individual human. Of course, there are limitations as well. Humans can learn from small collections of example data much better than a machine can. For instance, if you showed a human child several examples of a horse, maybe several pictures of different horses, you could then take them out and they would be able to correctly identify things that are and are not horses. On the other hand, Google's image recognition API has seen hundreds of thousands or even millions of examples of horses before it could achieve anything like the accuracy of a human child. So AI systems tend to need far more input data, far more examples than a human being would need. Humans also tend to be better in their ability to perceive and understand language, especially context and nuance. AI also has very limited generative capabilities. So there are AI systems already available that can recognize objects in images almost as well as humans can. There are systems that match or exceed the performance of humans in identifying faces in photographs. But on the other hand, there are few to no AI systems that can make music or generate art. So the generative ability of AI systems is still limited. So now let's take a look at machine learning specifically, which again is a subset of artificial intelligence. So the foundation of machine learning is actually probability theory and statistics. If you've only heard about, say, deep learning or neural networks, this might come as a surprise to you, but machine learning is old. It has been around since at least the 1950s, and it comes out of work in probability theory and statistics, as well as approximation theory, convex optimization, that sort of thing. So with machine learning, usually you have some mathematically defined input data, and then you have a mathematical function that you try to fit to that data, and then you have some error measure that you've defined that represents how good a job that mathematical function is doing fitting the input data. That's how most machine learning systems work. And don't worry, we won't be going into a lot of detail about how that's done. A lot of this is now implemented for you. If you use common machine learning libraries, all of that is done behind the scenes. So you really only need to understand what models are available and what their pros and cons are. So I actually like this Arthur Samuel definition of machine learning from 1959. Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. I think this is a great definition because it differentiates machine learning from other types of artificial intelligence. There are artificial intelligence systems that operate by being explicitly programmed. So you take knowledge from an expert about what to do in each situation, XYZ, and then you give the computer basically a set of if-else rules to follow for what it should do in particular situations. You can build fairly intelligent systems that way, but those systems don't learn on their own. That's the difference with machine learning. These systems learn without being explicitly programmed to perform a particular task. So in order to build a viable machine learning system, like for instance to classify spam and non-spam email, we need three well-defined things. We need a way to accumulate experience, E. We need some task that we're performing, and it needs to be a well-defined task, like saying yes or no, or giving a number as a predictive output. That's T. And then we need some way to measure our performance, P. So maybe an accuracy score or some other error measure that expresses how far our answer is from the correct answer. If you have these three things, a way to accumulate experience, a well-defined task, and a well-defined performance measure, then you can build a machine learning model. And the process is the same almost every time. You start by collecting data, you use that data to train your model, you evaluate your model to judge its accuracy, and then you deploy your model. And then usually you'll repeat these steps over and over. A big part of what Alibaba Cloud's platform for AI does is automates this process, or automates portions of this process to make it easier to go through these steps. Okay, so next let's take a look at platform for AI. I want to explain how we do AI and machine learning at Alibaba Cloud. And in particular, I'm going to focus on what we call PyDSW, Data Science Workshop, or Data Science Workbook. This is a Jupyter Notebook environment that we set up for you. You don't have to install anything. You can use it right from the web browser, and you can use all of your favorite open source machine learning tools in this environment directly. It's a great place to experiment. So what is Pi? Pi stands for Platform for AI, or Platform for Artificial Intelligence, and it provides data scientists and machine learning experts with an environment in which they can tag their data, process their data, train their models, evaluate their models, and deploy their models. It has tools to help you do all of those steps with the minimum amount of infrastructure configuration. So you don't spend a lot of time setting up virtual machines or Docker containers or installing software. Most of that is done for you by the Pi platform. So in order to do this, Pi presents you with an interface that's composed of different tools for different parts of the machine learning cycle. So we have tools like iTag to help you automatically tag data. There's tools like Pi Auto Learning to help you tune the parameters in your machine learning model. Pi EAS towards the top of the diagram here that helps you deploy your trained machine learning models. And then Pi Studio and Pi DSW on the middle left, those help you to build your model, train your model, and evaluate your model. We're going to be focusing mostly on Pi DSW. Pi Studio is a GUI only low-code tool for training machine learning models. PyDSW is a Python environment where you can write your own code. And all of these tools incorporate existing open source machine learning frameworks. You can use TensorFlow, PyTorch, Caffe, and more. And in a lot of cases, those tools are provided for you. You don't even have to install them yourself. Further, there's no infrastructure management with Pi, so all of the computing and storage is handled for you by the platform. You don't have to plan that out yourself. So why do you need something like Pi? So I have this wonderful diagram that actually comes from a paper that was published by Google in NIPS in 2015, Hidden Technical Debt in Machine Learning Systems. This is why you need a tool like Pi. Basically, when you're implementing a machine learning system in production, you're going to quickly find out that you spend a lot of your time doing data collection and configuration and security and monitoring and serving infrastructure for your trained model. All of that stuff takes up the majority of your time, and you don't get to spend that much time actually writing and tweaking your machine learning code, which is the tiny black box in the middle of the diagram. The whole point of Pi is to let you spend more time writing and testing machine learning code and less time managing everything else. So let's take a look at PyDSW, the Jupyter Notebook environment I've been talking about. So DSW here stands for Data Science Workshop. This is a web browser-based environment. It's essentially a Jupyter Notebook style environment where you can train and test machine learning code using Python. And you can install additional Python pip packages directly from this environment. You can upload and download test and training data directly from the web browser into this environment. It integrates with other tools like Object Storage Service and Max Compute, so you can pull data from those services and write results back to them. And you can even publish models that you've trained in here into the PyEAS model service. From the interface, not only can I open and manipulate multiple Jupyter notebooks, there's also a terminal, a Linux terminal, where I can install additional software packages if I need them. I can pull code from GitHub. I can integrate with other Alibaba Cloud services. I can upload and download files. And of course, on the right-hand side there, I can see my CPU and memory usage. And if I've linked a GPU card to my environment, then I can see my GPU resource usage as well. So with that, I think we should go try it out. Let's have a demo. So I'm going to show you how to set up a PyDSW environment on Alibaba Cloud, and then how to train a system, a naive Bayes classifier, to separate spam and non-spam email. Let's go do it. All right, so let's try and do something real with PyDSW here. So I'm in the Alibaba Cloud console. I'll click on the orange menu bar button at the top left there. We'll search for Pi. There it is at the bottom, Machine Learning Platform for AI. Click on that. That will take us over to the Pi console. Make sure we're in the right region. I'm going to use Singapore. So I'll double click on that. And then I will choose DSW Notebook Service. So from here, I can create a new DSW Notebook instance. And let's just take a look at what settings are available to me here. So I can choose the instance name. I guess I'll call it DSW Singapore JDP. That's my initials. We can see it's the individual edition, Asia Pacific Southeast 1 or Singapore region. I can choose pay-as-you-go only right now, but we will have a subscription service coming later. And then you'll see I can choose CPU type or CPU plus GPU acceleration. Obviously, those instances are more expensive, but they're more powerful as well. In Singapore, I can choose up to 4 NVIDIA V100s. I'll go with CPU only. That's powerful enough for me. And let me arrange these by price. We'll choose the cheapest type, a C6.large, that has 2 CPU cores, 4 gigs of RAM, and 128 gigs of disk. That will be plenty. You'll see also the way that DSW is set up, it provides only temporary storage, meaning if you shut down your DSW instance while you're not using it, and then you boot it back up, any code and data you stored inside the instance will be gone. So you want to add a NAS file system if you want to have permanent data and code storage. I don't need that for the demo, so I won't add a NAS, but of course in production you would want to do that. I then need to choose a disk image. You can choose PyTorch. There's a few different versions of TensorFlow available. I'm going to go with TensorFlow 2.3, and optionally you can attach your DSW instance to an existing VPC network group. If you needed to talk to maybe a self-built file server or maybe an RDS database or something, you could attach to the VPC that's hosting that resource. Now that I've made all my selections, I'll just hit confirm. You can ignore this warning in Chinese, sorry about that. This is complaining, or warning me rather, that I have not selected a NAS. So it's just reminding me that I will only have temporary storage. I'll say, I don't want to go back to the settings, so I'll click the button on the right here, and we'll just proceed to the next step. I'll agree to the user agreement and create, and that will start the process of booting up this instance for us. It should take us back to the DSW console where we can see the instance is being created. So now we just need to wait for the instance to get created. All right, great. So you can see that that environment is now up and running. So next I'm going to go ahead and log into that. So there's a button here that says Launch DSW. I'm going to click on that. That will open up a new tab. And then we're going to set up this environment by following along with the steps in this blog post here. This explains how the model works, where to get the code, where to get the example emails. All of that is explained in here. If you want to go and have a look at that yourself, you can scan this QR code. This QR code will take you right to that blog post. So I'll leave that up on screen for a moment. That way you can scan this and go visit the blog post on your own. Or if you prefer, you can just type in the URL. It's alibabacloud.com/blog/596462. That will take you here as well. I publish regular blog posts every Friday. So if you're interested at all in Alibaba Cloud technology, do go check that out. Okay, so now that we're in the environment here, you can see the first thing that I might want to do would be to open up a Python 3 notebook. There's also TensorBoard. I can edit markdown files. There's a terminal window. so I can get access to the workspace directly that way. But what I actually want to do first is open up one of these notebook files, a Python 3 notebook specifically. I'll hit select, and let's just test that this works. We'll just print hello. It works, save. I can, of course, rename this if I want to. There's a couple ways to do that. I could do it from the side menu bar here, or I could do it from the terminal window. So if I wanted to, I could just go back to the terminal and move that untitled file to hello.ipynb. Great, and you'll see in a moment it should show up under that new name. Might have to refresh the sidebar. There we go. Great. Let me open my terminal back up too. I'm going to need that in a moment. And the first thing we're going to do is go back to this blog post here and go find the instructions for uploading our model files and code and example emails. I've actually pulled the example emails from Kaggle, which is a common machine learning and big data competition website. So what we're going to do is follow the instructions right here in GitHub. This is the official Alibaba Cloud Academy team GitHub. We have a set of big data examples, one of which is this spam filter. And you can see it has an explanation of how to set up the environment. There's an explanation of where I ran the experiment, where it's been tested, what DSW instance type you should use, all of that. Most importantly, there's a link to the example email data that we're going to use. So I'm going to open that up in a new tab. And we'll go ahead and download a copy of these emails. I'm just going to sign in with my Gmail account here. Okay, here's the email data set. Wonderful. I am going to download the whole thing. It's 13 megabytes. It should only take a few seconds to download. I'll then unpack that. And you can see inside that archive file, there's a couple of other folders here. So you've got ham and spam, and spam. And if we go back to the blog, it will explain what data exactly go here. Actually, you can also just download a zip file if you don't know how to use the git command line. Just click download zip. That will fetch a copy of all the code in this repo, including the spam filter examples. We'll fetch that and open it up. Big Data Master, great. And then the other folder we needed was archive. Let's get a copy of that. All right, wonderful. I am going to take this email model file, put it in archive, and then let's double check how the email data should be formatted. We don't need all of it. We only need a subset of that data. So if we look back in the spam filter instructions here, you'll say that it'll show you that we need to go into ham and spam and actually remove one of the spam messages here, which is just a digest or a summary of the other emails. So, okay, I can go back here. We can get rid of ham and spam. We only need to keep ham and spam. And from within ham and spam, we need to remove this spam message 7B1B. So what I'm just going to do is grab that part there, go back into my folder here, drag it onto the terminal, remove. Okay, we got rid of that one email. Wonderful. We now have everything we need. So I'm going to rename this folder, archive. I'm going to rename it to email example. Let me do that. Stick it on the desktop first. Email example. Okay, and compress it. Wonderful. Email example. And then I'm going to upload it to the DSW environment. And while we're doing that, I also need to install some tools to help us parse and process the email example data. I need an LXML parser for Python. I need the Beautiful Soup toolkit for parsing HTML to deal with HTML emails. And then to actually train the spam and not spam classifier, I need to get a copy of scikit-learn. So I'm actually not using TensorFlow for this example. I'm using scikit-learn, which isn't included in DSW by default. So I need to install that. So we'll need to run this command. And actually, you don't need this user flag anymore. you can just do pip install and then bs4 lxml sklearn. So you know what? I'll open up a text document and we'll get rid of that unneeded flag. And then we'll go ahead back into the terminal and install those tools. And that should get LXML, Beautiful Soup 4, and sklearn. Okay, I'm using an old version of pip. It's okay, it shouldn't matter. All right, I now want to upload from my desktop emailexample.zip. And you'll see down here at the bottom, it says uploading. It's now taking that file from my local machine and uploading it to my DSW environment in Singapore. So we just wait a minute for that to happen. I can close some of these unused tabs. Okay, let's wait a couple seconds. And then once that's been uploaded, I will of course have to unzip it. The unzip tool is already built into the environment, so should be no problem to do. We just need to wait for the file to upload. Okay, there we go, unzip emailexample.zip, and that's going to unpack all this for us. All right, there we go. I can delete that junk macOS folder. There we go. I've now got my email example folder, my zip file. If I go into that email example folder, you can see here are my ham and spam emails, and then here is my model file. So this is actually going to unpack my spam and non-spam email, do some text processing to strip out HTML and other unwanted formatting content. It's then going to run them through a model and produce a result. So let's go through this and take a look at what each section of this code is actually going to do. So this first section here at the very top, what this is doing is it's reading in the ham and spam emails. So ham is the real email that you actually want to receive. It's non-spam. Spam is, of course, the junk email that you're trying to get rid of. So we have known sets of good email and spam email. And you'll see I'm using Python's email library to read those messages. And then BS4 is going to be used to pull text content from HTML formatted messages. And you see what I do, of course, is I build sets of the lists of the good email and bad email file names. So I have a list of file names to read in for my known good email, list of file names to read in for my known spam email. I then count up how many spam and non-spam emails there are, and I express those as a ratio. So I know the percentage of ham to spam, the percentage of good to bad mail. I then have a parser here that is basically just reading in those email messages using the Python email library. And then it is stripping the body part away from the headers. I actually don't examine the email headers to determine if an email message is spam or not. I only look at the body. So we're stripping off the headers, saving only the body. In this section here, I'm taking HTML formatted email and stripping off all of the HTML formatting, keeping only the raw text of the body. And then after I've done that processing, I print out an example good email and an example spam email, just so I can make sure that that stripping process worked correctly. And then the real heart of the code is here. So here you can see I'm actually building a model. I'm actually going to build and train my model in these two steps here and here. So here we're importing the count vectorizer class from sklearn. This is going to take each of the bodies of each of our emails and convert them into vectors of words. I'm then tagging each of those word vectors with zeros for items that are good email and 1 for items that are spam emails. So I'm building these vectorized representations of ham and spam email content. And then in the next step here, I'm actually feeding in my training and testing data to this train test split function, which is a built-in in sklearn. I'm then building a naive Bayes model, training it on my training set. So I've got my training emails and their labels, ham or spam. I'm training my naive Bayes on that data. Then I am testing it to calculate a precision and recall score to see how well the model works on emails it hasn't seen before. I'm then making some predictions and passing out the results so I can see how well the model did in the end. And then finally, at the very end, just to satisfy my curiosity, I've got this section here where I have written intentionally a fake good email, non-spam, and a fake spam email, and I'm testing the system to see if it can give them the correct labels. Of course, the good email should get labeled 0, spam should get labeled 1. So let's just run this thing top to bottom and see what it does. So you'll see there's different options up here alongside the top menu bar here. I want this one, restart the console and rerun everything. Let's do it. Great, so you can see the first part has already run. We have 500 spam emails and 2,500 non-spam emails. So this data set is only about 20% spam, which is remarkable. Normally you'd expect more spam mail. Let me expand out this sidebar here as well so you can see the CPU usage. Okay, so that spam email counting has now taken place. You can see the headers and body, the raw headers and body for some spam and non-spam messages here. All right, there we go. First spam message, you can see there's a big difference here between stuff that looks reasonable and stuff that is spam. As a human, it's pretty obvious, right? So you can see here it's someone talking about MP3 players with a friend, and then the spam message is, oh, solicit your strictest confidence. You see that, and right away you think, aha, spam. Then next, we go ahead and parse the HTML formatted emails to remove any HTML formatting and just keep the raw text. You can see the results after we do that. It's much cleaner. And then finally, we build and train our model, and it looks like the precision was about 99%, recall was 98%. So just on the basis of the words in the body, we can pretty easily differentiate spam and non-spam mail. And you can see that our fake ham message, our fake good message, got a score of 0. Great, so it was treated as good, as non-spam, and our fake spam message got a score of 1, meaning it was treated as spam. So we've now successfully imported our data, processed it, cleaned it, tagged it, passed it to scikit-learn, built a model, checked the accuracy of the model, and now from this point forward, we could go ahead and take that model file for that new model and publish it somewhere else like PyEAS, and then we could use it to perform inference on new emails as they come into our inbox. So that's it. That's how you use the PyDSW environment. And of course, once I'm done with all this, I would download any code and data I wanted to save from the environment, and then I could simply go back. I could go back to the DSW interface here and hit stop to stop the environment. Then I won't be charged for it anymore. Or if I'm completely done with it, I can hit delete and then hit OK, and that will shut down the environment and clean it up completely. It will be gone. And that's it. That's how you use PyDSW. So that's all for the demo. I'd like to thank you for joining me today, and if there are any questions, just let me know. I'm always happy to answer questions. If you want to reach out to me for any reason, you can do that via my Alibaba Cloud email address, which is this. It's jierui.pjr@alibaba-inc.com. So if you want to reach me, you can reach me at that email address. Again, thanks for joining, and I look forward to seeing you in a future session.
Hello.
All right.
Thanks, Jeremy. Thanks a lot for that wonderful session and the video. And probably we already have few questions from the community. I think they have been asking for a while now. I'll probably pick one by one. First things first, I think they wanted to know if they can get access to the slides. I'm assuming you can share them with the community. So that's one thing. And apart from that, yeah, so there is a question from Nina. The question is it a cloud platform? Is it possible to deploy to make deployment on the platform on customer service infrastructure? So this is a question from
Yes,
Nina.
actually, so my connection was bad a minute ago. I was trying to answer.
Hello, Jeremy. Seems we lost you a bit.
Can you hear me now?
Yes, 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 yes. Yeah, we can hear you now. Yeah. Hello, Jeremy. I think we lost you again a bit. Maybe shall we?
Hello?
Yeah, yeah. Now it is audible. Maybe we can turn off the video to save some
All right,
bandwidth.
I think I've got my connection back. Hello?
Yeah, yeah. You're audible. Great.
Oof.
Yeah, yeah. Perfect. Yeah, we can see you and you're perfectly audible now, I guess. Yeah, Jeremy.
I hope so. Fingers crossed.
Yes, 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 yes. Now it is perfectly audible. Probably, yeah, I mean, maybe you can go ahead and answer. I think you were already answering something. Yeah.
Okay, sure. So yes, I just wanted to address.
Okay, seems there is a small internet issue. We should be having Jeremy back in a couple of minutes or so. But meanwhile, you can feel free to put down your questions on the chat, and we'll be happy to address them. Yeah. Hello.
Sorry about that. Maybe we
Yeah.
can give
No.
that
No.
one more try.
Yeah. Yeah, no problem. I think it's fine now, and yeah, you can go ahead and answer the question. Yeah.
All right, thanks for being so patient. It's pretty tough to stream from China. It's hard.
Yeah, I know, I know. That's completely fine. Yeah, maybe you can go ahead. Yeah, thanks.
All right. So yes, I did see a few questions. The first was, can we get access to the slides afterwards? Yes, I'll make sure to share those.
Thank
Let's
you.
see what else. There was a question about from Nina, I think. That was the question
Yes,
you were talking about. Is it
yes.
possible to deploy this on your own infrastructure? No, unfortunately, no. It is something that's built into our public cloud platform. So you'd have to be on Alibaba Cloud to use this. If you wanted something similar on your own private infrastructure, you would have to build it yourself out of open source components. So you'd have to use something like the open source Jupyter Notebook plus IPython plus some other tools. You could put it together yourself, but it would be a lot of work. Um, can you get a link to access the Alibaba Cloud platform? Yes, yes, you can. But I'm sorry, it's not free. I mean, there's some free credits if it's your first time signing up, but there's no special offer for today's session. If you just go to alibabacloud.com and sign up for a new account, I think there's something like 200 or 300 USD worth of free credits. You could try those.
Yeah, true.
Yeah,
Yeah, yeah. I think there is some yeah, $300 or something free
something
credits
like
which
that.
they can
Yes.
use to utilize different services on the cloud platform. Yeah. And I think next question we have, can we get our hands on the cloud? I think this is something that you have already done, but if you want to add something to that, feel free to.
Well,
Yeah.
I don't see why not. I mean, again, you would just have to go get an account. So you
Yeah,
just go
yeah,
to
yeah,
alibaba.com and sign up.
yeah.
Yeah.
Yeah. And I think Nadir has this question. Is there any free tier of this service for those who want to learn working on this platform? I think this is also more or less addressed. They can get on a free trial and play
Yes.
around with the platform. And apart from that, I think, yeah, we have a question from Mayur. Is it possible to get 100% precision rate in this module? I think it's one of the modules where you're explaining about uh, the algorithm and that's the precisely the question about the evaluation metrics that someone is pointing out to. But yeah,
I mean, yes, it's theoretically possible to get 100% precision and recall out of a machine learning model. But if you do ever see that, It's pretty likely that you're overfitting, that something is wrong with the model or you don't have enough test data. As cool as it would be to have a model that's 100% accurate, chances are if you see that, something has gone wrong.
Yeah, got it. And then, yeah, and then there is this question: is this service available only on Alibaba Cloud or every other cloud? But I think, yeah,
Well, DSW, the data science workshop, this component is only available on Alibaba Cloud. But of course, I don't want you to think that, that's the only machine learning platform out there. I have to, say a nice word about AWS SageMaker too, right? They have their own machine learning platform on AWS as well. So yes, most clouds have something similar. Capabilities differ. I like our platform a lot, but you can find similar stuff on Azure or AWS. Sure.
yeah, got it. Thanks a ton for that. I think, like, those are some of the questions that we have on the community front, and we'll probably wait for. And someone is asking, can we get a free trial tier for students to learn? Is there any trial accounts for students that you offer, or
Well,
yeah,
that's fair. Yes, we do have, apart from the new user credits, we have a system we call AAEP, so the Academic Empowerment Program. If you go to edu.alibabacloud.com, that's the page that my team runs, the Academy team. We do all the training. That page on edu.alibabacloud.com, if you go there, there's a section on what the requirements are for the AAEP. And if you're a student, I don't think we give you this tool for free, but we will give you a server, a student server, a virtual machine that you can install anything you want on. So that's an option.
great, perfect. I think we have a new question. What is it to verify the confusion matrix and classification report? I think there is some more thought clarity that needs to be given to the question, but Jeremy, if you can add some
I
context.
can take a guess.
Yeah.
So, uh, basically, what the confusion matrix does is it allows you to check for two different types of mistakes. So when you're training a classification model, basically you're asking the system to make a yes or no guess, a yes or no judgment about each piece of input that you give it, right? So assume, for instance, in our case, we're classifying spam. My judgments are yes, this message is spam, or no, it's not spam, which means that I have two potential ways that I could be right and two potential ways that I could be wrong. The confusion matrix lets me judge how I'm doing in each of those different dimensions because I could correctly classify a message as non spam, or I could correctly classify it as spam. Those are the two ways to be right, right? But I could also get it wrong two ways. I could incorrectly say that the message is spam when it's not, and I could incorrectly say that the message is not spam when it is spam. So the confusion matrix lets me judge what type of error I have. And that's important because in a lot of machine learning applications, the two types of error are not equal. Being correct, both types of being correct are fine. But when it comes to error, sometimes it's worse to be wrong in one direction than the other. So let me give an example from medicine because that's an easy case where you can see why these things aren't the same. So imagine that I'm trying to train a machine learning system to recognize cancers. So you give it tissue biopsy samples and it's supposed to judge, does this person have cancer or not? Would you rather that system incorrectly say people have cancer when they don't have cancer? Or would you rather that system say they are cancer free when they're actually sick? Obviously, that second type of error is much worse. It's far better to accidentally say, oh, this person has cancer, and then send them for a surgery or a biopsy and find out it's nothing, than to have the system say, oh, they're healthy when actually they're sick. The outcome will be worse. So you actually care about these two different classes of error. They have different weights, they have different costs and benefits, and you have to use the confusion matrix to gauge how your model is doing in both of those error categories. I'm not sure if that's clear. I hope that cleared it up.
Yeah, I think that added some clarity. Thanks for that. I hope, uh,
Sorry, that really needs like a graphic. I'm just sort of waving my hands here. If you Google how to read a confusion matrix, there are some really good articles that have a beautiful picture that you can look at that's much better. Please do that. Oh, someone asked, where can I see your blogs? Oh, so the blogs are up on the Alibaba Cloud blog site. You can just go there. I also keep a record of them on my personal website. It's just my name. So it's just jeremypedersen.com. There's a section there called external publications, and that lists all my Alibaba blogs. But if you search around for things, I will show up. I publish a lot. So if you just search the Alibaba Cloud blog, you'll see me.
yeah. We will also probably share the link that you showed us, a while back, or probably
Yes, yeah.
yeah. We'll do that to the community, and yeah, I think there are a few people who joined in a little late, like Chris and a few others. But yeah, I mean, guys, this video will be there for you to watch later too. So feel free to watch it later on. So that should be fine. And
Oh, yes.
yeah, and there is a question from Philip. Is it possible to train model to another languages?
So I'm not sure if you mean another human language or another computer language. If you mean another computer language, yeah, sure. I mean, you could use Python or C or C++. There are good machine learning toolkits for all of those. I happen to like Python because, well, just because of the ecosystem. There's a lot of good machine learning tools that are already, written to work in Python. You don't have to do so much work on your own. If you mean human languages, yeah, I mean, there's machine translation systems out there. There's text generation systems like GPT-3. So sure. Okay, human language. All right. Yes, yes, you
Yes.
can train. So the way the model I actually showed you today should work on pretty much any human language, any written human language, because all I'm doing is building vectors of words for each email, for each spam and non-spam email, and then each word, regardless of what the word actually means, it just treated as a unique sequence of letters, right? So whatever the word actually means, all I'm doing is giving each word a score. How likely is this particular word to show up in an email? Doesn't matter. So it could be Hindi, could be Russian, Arabic. As long as you know how to split the email into individual words, you can train a model on it. Yeah, absolutely.
Great. Thanks for that. And also, I'm just putting up the blog link. This is a link to the blog. Okay. And there is another question from Nani. How can you explain that to validate the result for precision, recall, F1 score, and accuracy for each model based on values from confusion matrix and classification report?
Uh, that's a big question. We'd need we'd need a couple more hours for that. I'm not going to try. Sorry. Actually, you know what you should do? You know, DeFi, right? DeFi.tech, all those data science boot camps, maybe go check those out. I think that's too big a subject for me to address right now. It would take too long. I'm sorry.
Yeah, definitely. Nani, we will definitely send you a curated resource for that. We have a special, I mean, we already delivered a session on evaluation metrics and how you can calculate that and also how it helps
Yeah,
in
perfect.
calculating the
Yeah.
model accuracy. So we will definitely share that. Don't worry about it. And there is one question: how does email harvesting impact on the reputation of a company?
Hmm. Um, that's a hard one to answer because Alibaba is big enough that we get most of our user information organically from people signing up for apps. So I'm actually not sure. We don't really do that. I would imagine it doesn't help. It wouldn't be a favorable. It wouldn't be a mark in the pros column for your company if you're doing a lot of email harvesting. It doesn't look good. I have never tried it, so I can't say what the actual reputational impact would be.
Great, great. Yeah, no problem. I think Yeah, there is another question. If there is an image or video in the email, what do you say as the recommended way to classify them using Pi?
Well, honestly, when it comes to classifying spam, mm, for the most part, until recently, what you would do is you would just ignore that content. So that's what my script does. It only looks at the words in the body of the email. It doesn't care about formatting, doesn't care about images. Uh, but if you did want to handle that, what you would probably want to do is take any images that you found and actually pass them to one of the built-in OCR tools that we have. So we have a separate toolkit called Easy Vision. And what that will do is it will find text in images. So you might want to consider if you get a lot of, multimedia spam and there's spam content in the images, you would pass those to a service that can convert text in the images into raw text, into plain text, and then you'd process that along with the body of the email. That would be the way I would approach that. But in a lot of cases, you can get by just fine with the words that are actually in the body of the email. That's enough to classify most spam.
Great, got it. Yeah, thanks for that valuable insight, Jeremy. I think I can see that, like, that's pretty much on the community end. And before, okay, there is another thing before we wrap up. DSW is only available in Alibaba Cloud. Okay, for the moment,
Oh,
yeah,
okay. I thought I answered that one. Sorry.
yeah, you
Um,
already answered. Yeah, go ahead. Yeah.
so it's not available anywhere else. DSW is specific to Alibaba Cloud.
Got it. Yeah. Thanks a lot for that. And before we wrap this session, any final thoughts that you would want to share with the community? Anything that you have from your friend in terms of for someone who is getting started with data science or NLP or deep learning, what is the advice you would give? Or if there is anything that you would share with the community, that will be great. And also, I think we have one more question, but yeah, after you answer this, we'll probably pick that up. Yeah. Thanks. Yeah.
Okay, sure. So the one thing I would say that I think is really helpful is you should try to find some competitions or hackathons to participate in, because that will give you a hard deadline and it will push you to learn things faster. Kaggle, for instance, is a good resource for that. So make sure that you're actually pushing yourself to participate in some of these things. My own experience with data science has been that if I'm doing it on my own time, I don't move very fast. So it helps to have a competition.
Yeah, totally. I mean, totally aligned with that. And also, there is a lot you can do with community learning aspect to
Absolutely.
it, right? You learn as a community, and that's something that we promoted DeFi as well. Like, especially with our boot camps and other sessions as well, we promote community learning very, very prominently in the community.
Yes,
And
don't do
before
that. Don't
we
do it on your own. Don't do it on your own. Be part of a community. That's very important.
Thanks for the sweet advice, Jeremy. And before we wrap up, I think we will pick the last question. Do emojis in email affect the classification as spam or not spam?
Huh. Yeah, I'm getting some good questions today. I like this. In my classifier, no, because I drop anything that isn't English text. But you could actually, that might be a good thing to check for. I'd never thought of that. But yeah, you could potentially use emojis to classify as spam. You just have to treat each emoji as a word and then give it a spam score, just like you do with the text.
Yeah, totally. Thanks. I mean, it's all about handling those additional edge cases, and I think as you prolong, you'll identify more edge cases and you'll tune your algorithm better. So it all goes with the
Absolutely.
learning process. Yeah, thanks a lot, Jeremy. Thanks a lot for joining in, and thanks to the entire community out there for proactively engaging in the session. I'm sure, like Jeremy has enjoyed addressing the questions as much as he delivered it. And thanks once again. Yeah, have a great rest of the evening or rest of the day. Thank you.
Thanks, everyone. Thank you very much for the invite.
Yeah, bye.
Bye bye.